Scotty, I'm Tony. That's Ned, and this is Nam. And James regrettably couldn't be here, but he's here in spirit. So our project is basically world domination. So we're gonna create robots that will one day start with combat simulation and hopefully one day enslave us. So
we may have to scale down to maybe just California for now.
Yeah.
But this is part of the overall plan.
Yes. So actually, we're starting out with basically just two robots that are going to hunt each other. One of them is going to act like a supply truck trying to navigate through a city and get to an escape point, and the other is going to be trying to find it and blow it up before it gets there. So the general concept is we're kind of looking for one of them with basically an escape and avoidance, collision avoidance, and hopefully shooting avoidance algorithm, and the other one's kind of a hunter-killer type thing where it's going to look for the moving obstacle and try to use sensors to try to destroy it. And the kind of sensors we're thinking about are mostly sonar or infrared or radio waves. I mean, obviously the robot's going to be the avoidance robot's going to be a little more cooperative in terms of feeding signals back and actually letting itself be detected in some way or form. You know, that's a little less realistic in real life, but this is our starting point. So we're breaking this thing up into milestones where, you know, our first milestone is actually just creating the framework for the Roomba. I mean, we're either leaning towards Mindstorms or the Roomba, but since the Roomba already has our project is fairly ambitious to begin with, so since the Roomba already has an existing infrastructure and we're familiar with it and we've actually done some work on it, we're thinking of adding onto that platform and using the Luminary microcontroller to actually do most of our processing. So basically, we're going to start out with getting that framework working with the sensors and actuators and getting the robot working to make sure that the sensors we have will interface nicely with the Luminary and things along those lines. And then we're going to send and receive beacon signals. So basically, we're just going to put a beacon, like either a sonar infrared beacon somewhere in the room, and have the robot try to find it and navigate and make a decision on where to go to find that beacon. Then we're going to have the defensive tank actually do the build and hit algorithm. So basically, if it gets hit, it'll somewhat detect it. So we're going to have it hopefully built by Calday. Hopefully we'll have all our tanks built by Calday. And then we're going to do moving obstacle avoidance. So basically, actually going through, trying to find the escape beacon and navigating through a simulated city, which is basically going to be cardboard or wood boxes or something along those lines, something kind of hokey, but you know, it's just so we kind of get the feel that it can navigate through a city and navigate through city streets and try to escape. And then we're going to have target seeking. We're going to have the hunter robot actually try to find the moving robot that's navigating through the city and shoot it with a USB tank. And the shooting thing we're going to use a missile, the USB missiles. And we're using USB missiles primarily because Soviet tanks are kind of expensive. And we're using so we're actually using like these little foam missiles. And plus we're thinking of maybe either using some kind of touch sensor, some panel that'll sense the hit detection, or either an RFID tag on the tip of the missile that once it gets kind of in the sphere, kind of at least in the ballpark of where the Roomba is, that it'll actually register as a hit.
And of course, when we scale up, a few thousand USB foam darts all stuck together should be just the equivalent of your standard hunter missile. So.
Microphone. We're really prepared for this. So, would you like to say that again, or?
Oh yeah. So when we scale this up, having a few thousand foam missiles duct taped together should be the equivalent of your standard hunter missile.
Okay. So that's the direction that we're heading in, and that's I mean, there's definitely a lot of things that we need to explore and things that we need to prepare for, but I think we've got a really good idea. I think it's realistic to actually implement, especially if we do use the Roombas, because like I said earlier, we do have that existing platform. We all are somewhat familiar with it, and we can all see code mostly, except for me. I'm kind of terrible, but it'll be fine. So do you have any questions? I guess I'll open this up. Scott.
Number 9,
Flare.
Oh,
Flare.
That's some fun stuff.
Yeah.
So things like, I mean, when you actually
Scott.
Oh, thank you. Yeah, so the question was number 9, flare, which we didn't really talk about too much. So in the real world, when you blow up a supply transport, it shatters into a million pieces. So if we get this far to 9, we would actually like to do that, so then we can show all the the debris flying around, and we can model that, and probably not actually do anything scientific with it, but Man, would that be cool?
Yeah, Professor Lee is really kind of being a tightwad about the fireworks. So, so pyrotechnics and things like that, he said it wasn't very realistic.
Our first idea was to use Roman candles.
Yeah.
But that's probably not going to fly too well.
Yeah, so we're kind of playing with maybe some confetti or something like that, or maybe some party poppers or something along those lines. That'd be a little less explosive. Generally won't cause fires. So maybe some silly spray, but flare also maybe some more buttons, like if you could pin them to the suspenders of the robot.
Not like we haven't caused enough fires in the labs already.
No. And
You stated you're going to use a panel for hit detection, right?
yeah.
That would mean the underseeker would actually need to have visual systems to actually find it?
No, we're actually using visual systems, especially on the Luminar microcontroller, is completely unrealistic. It won't be able to process it. So we're going to use a general sound beacon and kind of just have the thing be oriented a certain way. Either instead of having maybe one panel, have four. So you could have four, basically a box, right? I was speaking kind of generally, but the idea is basically that it shoots it, it hits it, it registers a hit. I mean, that's what we're playing with right now. We're trying to think of either if it's RFID is the best way to do that, or if it's, just basically physical. Maybe a physical system would be better. I mean, we're still exploring. Does anybody else have any questions?
Yeah, and of course, when you scale this up, the blast radius, you shouldn't have to be too close to actually hit something. With ours, we're going to need to be close enough to at least register a hit. But in the real world, as long as you're within, a mile radius or so of a nuclear explosion, it shouldn't be too bad.
Any other questions? Nope. Thanks.